$100 million, 80 meters of steel and glass, a floating city.
It looks effortless, but it starts as a brutal industrial war zone.
More complex than a jetliner, more custom than a mansion.
4 years of labor, thousands of hands, zero margin for error.
This is Project 812, a custom commission for a billionaire who demands perfection.
How do you make 2,000 tons of metal float and travel at 20 knots? Inside, materials sourced from 3 continents meet aerospace precision.
But before the champagne flows, the first line must be drawn. It begins with a napkin sketch and evolves into naval architecture. Every pipe, wire, and bolt is modeled in 3D before a single piece of metal is cut. Engineers test hull efficiency to ensure range and stability. The owner wants a helipad, a submarine garage, and a beach club. Sourcing begins. Marine-grade steel from Germany, aluminum from Norway. Trucks arrive with massive steel plates, the raw ingredients of a superyacht. The ship isn't built in one piece. It's built in blocks.
Plasma cutters slice the steel with sub-millimeter accuracy.
If a cut is off by 2 millimeters, the blocks won't fit together later. Flat plates must be bent into complex compound curves for the hull.
Computers guide the press, but the human eye checks the curve.
The puzzle pieces are ready. Now, the welding begins.
The keel laying, a maritime tradition marking the birth of the ship.
Welders work around the clock to fuse the skeleton.
These welds must withstand ocean storms. There is no room for porosity. Inspectors use X-ray tech to see inside the metal joints.
Hull sections are often built upside down for easier welding access.
Block by block, the length grows. The seams are welded shut. The bulbous bow is attached. It modifies water flow to save fuel. Inside, ribs and stringers provide the structural rigidity. The steel hull is heavy for stability. The top needs to be light. The superstructure is crafted from aluminum to lower the center of gravity.
You can't weld steel to aluminum directly. They use a special transition joint called triclad. Deck 1, Deck 2, the sun deck. The yacht gains its vertical profile.
Before the hull is closed, the heart of the vessel must be inserted.
It's time to give this floating palace its power.
Twin MTU diesel engines, each the size of a school bus.
A delicate operation, lowering 60 tons of machinery with millimeters of clearance.
They sit on active mounts to dampen vibration. No coffee ripples allowed upstairs.
Long steel shafts connect the engines to the propellers outside.
The engines move the ship, but generators power the lifestyle.
Scrubbers and filters clean the exhaust before it leaves the stack.
Gyro stabilizers and fins keep the yacht flat in rough seas.
For tight maneuvering in Monaco, powerful bow thrusters are essential. Miles of color-coded piping carry fuel, water, and hydraulic fluid.
Massive chillers ensure the Caribbean heat never enters the cabin. Desalination plants turn seawater into crystal clear drinking water. Now begins the most tedious task, pulling the cables. Over 200 kilometers of wire run through these trays. The main switchboard distributes power like a small city's grid. Complex systems allow mood lighting to be controlled from an iPad. Server racks, rivaling a tech startup, manage internet and security.
The engine room is boxed in acoustic cladding. Silence is the ultimate luxury.
High-pressure mist systems stand ready to extinguish any flame instantly.
Engineers run dry tests on the electrical circuits.
The guts are in. Now the rough metal skin needs a tuxedo.
Fairing, the art of making metal look like glass.
The yacht is tented. Humidity, temperature, and dust are strictly controlled to create a laboratory environment.
Master painters apply the high-gloss top coat. One speck of dust can ruin $1 million finish. Acres of Burmese teak are laid by hand on the decks, a natural contrast to the steel and glass. Black caulking seals the wood and provides the grip needed for wet feet.
Once dry, the deck is sanded to a soft, golden finish that feels like velvet.
Massive panes of reinforced glass are craned into place. These windows must withstand hurricane-force waves.
The glass isn't just framed, it's bonded directly to the structure to become part of the hull's strength. Polished stainless steel railings are bolted down. Jewelry for the exterior.
Keep it coming down slow. All right, we're clear on this side. Set her down.
The outside is ready for the ocean, but the inside must be ready for the owner.
Floors float on rubber mounts to eliminate engine vibration. No ripples in the wine glass.
Layers of rock wool ensure privacy and temperature control. The harsh marine environment stays outside.
The interior is built in a workshop, then assembled on board. It's a puzzle of 1,000 pieces.
Wall panels click into place with micrometer precision. There are no gaps in a superyacht.
The owner hand-picked this marble from an Italian quarry.
To save weight, marble is sliced thin and backed with honeycomb aluminum.
A commercial-grade kitchen capable of serving 50 guests.
The central staircase is a structural masterpiece.
Custom furniture is brought in. Everything is bolted down.
A gym with a view, and a spa with a steam room. Priceless art is hung on the walls. Hand-woven silk carpets are rolled out. Luxury is complete. Now, control is needed.
The bridge looks more like a spaceship than a boat. Redundant GPS, radar, and sonar systems.
The ship can hold its position automatically without an anchor.
Cameras cover every inch of the exterior.
Satellite domes ensure high-speed internet anywhere on Earth.
From the bridge, the captain doesn't just steer. He monitors the heartbeat of the vessel. Real-time telemetry tracks cylinder pressure and exhaust temperatures.
When the sun sets, thermal imaging takes over, allowing navigation through pitch-black waters by detecting heat signatures miles away.
The captain's chair. Ergonomically designed, wrapped in Italian leather, and positioned for total command of the horizon.
Before the lines are cast, the crew runs simulations. Muscle memory is built here, so there are no surprises out there.
All systems report green. The dry dock has served its purpose. It is time to introduce the steel to the sea. Massive sluice valves open. The ocean rushes in, swirling around the keel blocks, rising to meet the hull. Physics takes over. Archimedes' principle in action. For the first time, 2,000 tons of metal defies gravity and lifts. She has no power yet. A fleet of tugboats coaxes the giant out of the shed and into the open harbor. In open water, the order is given. The main engines roar to life, turning the shafts and biting into the ocean. Sea trials begin with the speed run, full throttle, pushing the propulsion system to its absolute theoretical limit. Then, the torture test. Hard overturns to stress the steering gear and prove the stabilizers can handle the shift. Inside, it must be serene. Engineers perform the coin test. If it falls, the vibration dampening has failed.
The anchor drop. A violent
Noisy but critical test of the windlass brakes and chain integrity.
Trials are passed. Back at the dock, the crew swarms the deck for the final detail. Salt spray is washed away. The moment of truth. The owner arrives. A handshake on the aft deck marks the end of construction and the beginning of ownership.
It took millions of man-hours. A symphony of welders, carpenters, electricians, and engineers. The result is a convergence of heavy industry and fine art. A floating palace built to survive the wrath of the ocean.
She will now travel the globe, a self-contained island of luxury, leaving the shipyard far behind.
It stands as proof that with enough engineering, precision, and ambition, even cold steel can learn to fly. This is the pinnacle of shipbuilding. This is the super yacht.